You know, you're using an AI, and one minute it's writing a beautiful sonnet, and the next it's doing something that makes absolutely no sense. Well, today we are going to pop the hood and find out exactly why that happens. Let's start with a few frustrations I'm sure you've all felt.
Right? We've all been there. You're having this great, detailed conversation with a chatbot, you've laid out all the context, all the key facts, and then poof! It's like it has total amnesia. Why in the world did it forget something you said just a few minutes ago?
Or how about this one? You hear about the latest, greatest, biggest AI model, and you think, okay, this is going to be a huge upgrade. But when you use it, it's slower, it costs more, and honestly, it doesn't even feel that much smarter. So what is going on there?
And then you get the stuff that is just truly weird. You ask this AI, this thing that runs on a supercomputer, a question a 5-year-old could nail, like, hey, how many R's are in the word strawberry? And it gets it wrong. How is that even possible?
Okay, so these might seem like totally random, unrelated glitches, but they're not. The answer to all three of these mysteries isn't some kind of digital magic. It's actually pretty simple. It all comes down to understanding the machine itself. Let's get into the mechanics.
So here is the big idea for today. I want you to think of every AI model out there as a machine. And this machine has 3 main dials on the front. If you understand what each of these dials does, all of that weird behavior suddenly starts to make perfect sense.
And here they are, the 3 dials. First, you've got parameters, which is basically the size of the AI's brain. Second, you have tokens, which are the actual units of thought it uses. And third, there's the context window, which acts as its short-term working memory. These 3 things, they explain pretty much everything.
All right, let's dive into that first dial, parameters. Again, you can just think of this as the brain size of the model.
So what are parameters, really? Well, you can think of them as millions, or these days, billions of tiny little knobs inside the model's brain. Each knob is a number, and all these numbers together are what hold the compressed knowledge from all of its training. They represent every pattern and connection the AI has learned.
Now this is where it gets really interesting, because we all have this assumption that a bigger brain, more parameters is always better, right? But look at the chart. That giant, top-of-the-line model is way more expensive and much slower. The mid-tier one is fast and cheap, and for a whole lot of common tasks, the quality you get out of it is basically the same.
And this quote just hits the nail on the head. Because training methods are getting so much better, a smaller model from the near future could easily outperform a giant model from today. So what's the big takeaway here? Don't just chase the biggest number. Pick the model that actually fits your task and your budget. Okay, on to our second dial, tokens. This one is all about how an AI actually sees the words you type. It's its fundamental unit of thought.
This is such a perfect illustration. Look at the left. When you see strawberry, you see a string of individual letters. But the AI, it sees what's on the right. It sees chunks, these tokens like straw and berry. And here's the kicker. It has no idea what letters are inside those chunks.
And there it is. That's the solution to our strawberry problem. For the AI, those tokens are like solid, indivisible atoms. It literally can't look inside them to count the letters. All it can do is make a statistical guess based on what it knows about the token strawberry, which is why something so simple for us can be so hard for it.
So here's the practical advice you need to hear. If you're asking the AI to do something on a character level, like counting letters, spelling a word backwards, anything like that, trying to write a fancier prompt is not going to work. You're fighting how the machine is built. The real fix is to give it a tool, like a little bit of code to do the job for it.
All right, let's move to our third and final dial, the context window. This is the one that controls the AI's ability to remember your conversation.
So the context window is basically the AI scratch pad. It's the total amount of text, everything you've typed and everything it has typed back that it can look at in one go. It's a working memory, not a permanent hard drive, and that difference is absolutely crucial.
You know, this is probably the biggest misconception about how these things work. When an AI remembers what you said earlier, it's really just a clever trick. The chat app you're using is resending the entire conversation history back into that window with every single new message. The model itself is actually starting from scratch every single time.
So why does it forget what you told it 10 messages ago? It's usually one of 2 things. First, your conversation just gets too long for the window. The app has to start chopping off the beginning of your chat history. Or second, even if it fits, your key instruction might get buried in the middle of a long conversation, a place we now know these models just don't pay as much attention to.
So, we've looked at each of the 3 dials, parameters, tokens, and context window. Now let's put it all together. To really get the most out of these tools, you just need to know the right 3 questions to ask yourself.
And this right here, this is your new cheat sheet. For parameters, which control cost and speed, you ask, which model is the right fit for my task? For tokens, which control how it sees the world, you ask, how should I structure my prompt? And for the context window, its working memory, you ask, how can I make the best use of its limited memory? And once you start thinking in terms of these dials, you suddenly see why all those public AI leaderboards and those breathless headlines about Model X crushes Model Y can be so misleading.
And this is exactly why. A benchmark test might be all about tasks that reward a massive brain, a huge parameter count. But maybe your specific job depends entirely on having a massive working memory, a huge context window. So you can have 2 models get the exact same score on a test, but feel completely different when you actually try to use them, because the test wasn't measuring the dials that you care about.
So, the real power doesn't come from a score on a leaderboard. It comes from understanding the mechanics. You now know about the 3 dials that control an AI's cost, its perception, and its memory. So I'll just leave you with this question. Now that you know how the machine actually works, will you ever look at a simple AI leaderboard the same way again?